Friends, in this lecture we will study graphs of real valued functions of real variables. For graphs of real valued functions of real variables, domain is subset of x-axis and codomain is subset of y-axis. The graph of function is obtained by collecting all pairs of pre-images and images. Pre-image is point x, which is on x-axis, and image is point y, which is equal to fx, and it is on y-axis. And if we collect all such points, then we obtain graph of a function. Let us see graphs of some standard functions. Here I have plotted the graph of x square. Now let us plot the graph of x cube. This is graph of function x cube. Let us draw graphs of some trigonometric functions. First we will plot sin x, sine wave. Next function cos x, next function tan x, it is unbounded function in the standard interval minus pi by 2 to pi by 2, and all these functions, trigonometric functions are periodic. Then let us plot graph of exponential function. This is graph of exponential function. Finally, let us plot graph of logarithmic function. It is better to remember these graphs of standard functions. Let us proceed to understand few more relations between graphs of real valued functions of real variables. The graph of f of x minus a is obtained by horizontal shift of graph of fx through amount a. Here I have plotted the graph of x square. The graph in red color is that of x square. Now the problem is to plot graph of x minus 1 bracket square. That is, we want to plot graph of f of x minus a, where value of a is 1. So here you can see we have two graphs. Graph in red color is that of x square and graph in blue color is that of x minus 1 bracket square. So here you can see for different values of a, how we can obtain graph of f of x minus a. Remember first relation which we are studying. The graph of f of x minus a is obtained by horizontal shift of graph of fx through amount a. This relation is not only applicable for the function x square, it is applicable for all real valued functions of real variables. For example, let us take graph of sin x, and now we want to plot graph of sin x minus 5. So graph in red color is that of sin x and graph in blue color is that of sin x minus 5. For different values of a, we can see how the graph in blue color gets changed. For example, if I want to obtain say graph of sin x minus 2, this is how I can obtain. Just I need to horizontally shift graph of sin x through amount 2, and that will give me graph of sin x minus 2. First relation we are done. Remember, the graph of f of x minus a is obtained by horizontal shift of graph of fx through amount a. Let us proceed for next relation. So next relation is between graph of f of x plus b and graph of fx. By knowing graph of fx, we can obtain graph of f of x plus b. How to obtain graph of f of x plus b? By knowing the graph of fx, we simply have to vertically shift graph of fx through amount b. Here I have plotted graph of cos x, and the problem is to obtain graph of cos x plus 1. So you can see we are having two graphs. Graph in red color is that of cos x and graph in blue color is that of cos x plus 1. So this is graph of f of x plus b. Again, this relation is universal. It is applicable for any real valued function of real variable. We can try this for different functions, like say x square. So let's see this x square. Okay. So graph in red color is that of x square and graph in blue color is that of x square plus 1. For different values of b, see how the graph of x square plus b gets changed. There is just change in shift of vertical amount. So this technique is very useful to draw graph of f of x plus b when we know graph of fx. Remember, the graph of f of x plus b is obtained by vertical shift of graph of fx through amount b. Let us proceed for next relation. It is graph of f of minus x. Here, graph in blue color is that of x cube. Now, we want to plot graph of f of minus x, that is minus x cube. So, how to obtain graph of f of minus x? By knowing graph of fx. In order to obtain graph of f of minus x from graph of fx, we have to take reflection of graph of fx along y-axis. If you carefully observe the relation between these two graphs, graph in red color, which is graph of function x cube, and graph in blue color, which is graph of minus x cube, you can observe that these two graphs are mirror images of each other along y-axis, that is along the line x is equal to 0. This relation is again universal. It is applicable for all real valued functions of real variable. We can try it for different functions. Let us try it for exponential function e raised to x. Exponential function. So graph in red color is that of e raised to x. Graph in red color is graph of function e raised to x, and graph in blue color is graph of e raised to minus x. You can easily observe that these two graphs are mirror images of each other along y-axis. Let us proceed for next relation. Graph of minus fx. It is different from the earlier relation that we studied. In earlier relation we studied graph of f of minus x. Here we are having the graph of minus fx. The graph of minus fx is obtained by taking reflection of graph of fx along x-axis. Here I have plotted graph of x cube, and it is the curve represented in red color. Now the problem is to obtain graph of minus fx, that is minus x cube, and we can observe that the relation between red curve and blue curve is they are mirror images of each other along x-axis. Let us try this relation for another function, exponential function. Okay, so here graph in red color is graph of e raised to x, exponential function e raised to x, and graph in blue color is that of minus e raised to x. You can easily observe that these two graphs are mirror images of each other along the line y is equal to 0, that is along x-axis. This relation is again universal, applicable for all real valued functions of real variables. The graph of minus fx is obtained by taking reflection of graph of fx along x-axis. Finally, we will study the relation between graphs of functions and graphs of its inverse functions. So whenever inverse is defined, there is specific relation between graphs. The graph in the graph in red color is that of e raised to x, and graph in green color is its inverse function. So as you know, logarithmic function is inverse of exponential function. Can you observe some relation between these two graphs? Graph in green color is reflection of graph in blue color along the line y is equal to x. So whenever functions are invertible, we have this relation. The graph of f inverse x is reflection of graph of fx along the line y is equal to x. Let us try this for some function. Let us say x square. So if you observe, if the graph in red color is that of x square, it is not invertible function in the whole domain, but it is invertible, let us say, in the domain 0 to infinity. So just let us concentrate on this part. In first quadrant, you can observe that these two graphs, x square, what is inverse of x square? It is square root of x. So the graph in green color is that of square root of x, and graph in red color is that of x square. And you can easily observe that these two graphs are reflections of each other along the line y is equal to x. So if function is invertible, then, and if we know graph of function, then we can obtain graph of its inverse function. In next lecture, we will study continuity and differentiability of real valued functions of real variables. Thank you.